Hello everyone. For this module, we will be learning about the technical side of MIS. We will begin with the basics of hardware, then we will move on to software, networks and protocols, and databases and warehouses. Okay? So, just a brief introduction on why we should study the technical side of MIS. As said at the start of the semester, your goal as MIS personnel is to bring information to people through data. You need to connect humans with technology because in order to transform data into information, you would need to leverage your technology to do so. That being said, MIS personnel should know technology trends, which technology are obsolete, and the best technology solution for a given situation, so that yourself and your clients can invest wisely in technology and not overspend. Think about it this way. You have a client that is a production house manager wherein they do tons of video editing. Hypothetically, they need 20 new units for their office, and your client asks you for recommendations on which technology to buy. You, being the specialist, right, decided to give them an iPad Air. I mean, you can video edit with an iPad Air, right? But we all know that this isn't sufficient enough. You need something more powerful. In a sense, you just wasted your client's investment in new technology, right? Um, there is not much value in the recommendation that you made, the iPad Air, because they really need something much more powerful for heavy video editing because they will be using it to video edit ads and the sort, right? Given that they need heavy video editing, you would probably lean towards a new PC, a custom built PC, or a laptop with high memory, great graphics card, and a decent processor. Okay, that being said, um, let's now move on to our first lesson, which is hardware. Hardware refers to the physical components of a computer. These are the tangible things. This includes your monitor, your mouse, your keyboard, and other things that you could touch. Okay? Now, hardware is divided into four components. You have your input, processing, storage, and your output. Okay, start off with the input first because this is the much easier between the four of them. Okay, so let's start off first with input. Input devices have two main functions. First, it acts as the medium to communicate with your computer. Through input devices, we are able to tell what the computer should do. These include your mouse, your keyboard, your trackpad, your touchscreen, your controllers, anything that allows you to communicate with your device, right? So, for example, if we type on our keyboard, we are telling the computer, okay, I want this typed out. If we are moving our mouse, if we are clicking, we are able to tell the computer where to go and what to do. Yes. Okay. Next up, we have the second function for input devices is that it is used to capture data. Okay, it captures the data and sends it directly to your computer. Included here are your microphones, digital cameras, sensors such as environmental sensors that measure temperature, vibration, moisture. It can also be an RFID. Okay, so it will capture data. Like how your microphone works is the mic captures the sound, right? Turns it into a bunch of ones and zeros because it's gonna turn it into digital data and sends them to the computer. A quick note though is that all data and instructions in digital technology as we are using now are a series of ones and zeros, or what we want to call binary. We will learn more about binary later when we get to the processing component of hardware, okay? So, just a quick recap. Input devices, okay, have two functions: to communicate with your computer and to capture data to send to your computer. All right? Now, let's move on to the next component, which is output. Output devices are how your computer communicates with you through your senses such as visual, audio, or touch. if there are devices for smell and taste, do let me know about them because I'm not familiar pa with them right now. So these devices are your monitors, speakers, screens, printers for sight, and or audio. Okay? For touch, these can include your video game controllers. Controllers are both input device and an output device. Just think about it, right? On the one hand, it is an input device, the gaming controller, because of the buttons and the analogs that you press, you're sending signals to the computer. But it can also be an output when it vibrates, right? Vibration is a form of output as well. Again, output is how your computer communicates with you. Next up is processing. Now, we are going to get a little technical and in depth on the processing point to help you better understand how a computer works. Okay? So, your CPU, or a common term processor, we call it a processor, is the brain of your computer. From how you type things on your keyboard to how you hear the audio of your videos, all of these pass through your processor. Okay, they pass through the brain of your computer. Examples of processors are your Intel Core i7, AMD Ryzen, processors. Okay, a processor is made up of a bunch of transistors. Okay, the transistor is shown like in this image over here. That this is a model of a transistor. Um, Power goes through the left side. Okay, so the power will go through the left side over here, the left line, and there's a switch here that allows the power to go through or not. Okay, so the switch is either turned on or off. Um, so in a sense, these transistors are switches that help the computer understand your instructions. Switches are either turned on or off, and these correspond to your ones and zeros. 1 for it being turned on, and 0 for it being turned off. Switches can only be either off or on and nothing in between. Hence, we have the term binary. Okay, that's why it's ones and zeros, binary, only on or off. So think about it this way, right? Let's talk about numbers for a quick bit. Uh, which number do you think is bigger, 121 or 98? All of us will think that it's 121, right? Even though the numbers are smaller, you only have 121, and the other number has 9 and 8. You know 121 is larger mainly because it has more digits, right? It has more digits than 98. 121 has 3 digits, while 98 has 2 digits. It works the same way for a processor, okay? A transistor, okay, this transistor over here, corresponds to the number of switches your CPU has. Or in this case, the number of digits your CPU has. Okay. The more digits your computer has, the better, the faster it will work. I will be posting a supplementary slide on binary for you on Moodle to better understand this concept. Feel free to ask me about this as well if you want, but I will move on because binary is not included in our module. Okay, let's move on. The key thing to remember here is that the more transistors you have on your CPU, it will make your processor faster. And hence, we have Moore's Law. Intel co-founder Gordon Moore predicted that the number of transistors fitting on a processor would about double every 18 to 24 months. Okay, so imagine a processor, okay? Just imagine a chip, a square chip. The number of transistors on that chip will double every 18 to 24 months. So this is not about making the chip bigger, okay? You're not making the processor bigger, but rather making the transistor smaller and smaller so that you can fit more onto the chip. The trend of doubling every 18 to 24 months is still being followed until this day. Okay, so here, okay, let's move on. So here we have the CPU. Again, the CPU is made up of a bunch of switches, And the main parts of the CPU are the following. Okay, we have our arithmetic logic unit or ALU, we have our control unit, and we have our register areas. So let's start off first with the ALU. So the ALU, think of the ALU as the processor's calculator. Okay, so um, it does arithmetic, as in the name, right? Arithmetic logic unit. It does arithmetic, so it does addition, subtraction, multiplication, and division. Okay, of only two inputs. So you can do 1 plus 1, 2 minus 1, 3 times 3, 4 divided by 2. That is the basic calculations that the ALU can make. That is the arithmetic side. Next up is your logic side. Okay, so it's three things, right? Arithmetic, logic, unit. Logic, we mean by the ALU compares two integers. Okay, it is comparing, meaning it is either greater than, equal to, less than, greater than or equal to, less than or equal to, or not equal. So the ALU compares two values and it will return either true or false based off the inputs that you put. Okay, so this is the ALU. This is the like the calculator of your processor. Next up is the control unit. Think of the control unit as the manager of the processor. Okay, it instructs where things have to go and how. The control unit sequentially reads the instructions, decodes it, and tells everyone how to do the task. So, remember the things that we are typing on the keyboard or whenever we are moving the mouse? We said that it passes through the CPU, right? So, for example, you type something on your keyboard, it will pass through the CPU. So, the control unit will try to analyze what you actually type. So, for example, the control unit will see, oh, user inputted the letter H for his first command. So then the control unit will tell someone, okay, you over there, I saw an H here, so type the letter H for our user. That is what the control unit will do. Okay, that he is sort of like the manager that instructs everyone on what to do in the CPU. Next up, we have our registers. Okay, so registers are the storage of your CPU. They are the memory found inside your CPU. The storage of registers are small, right? If we think about storage, for example, I guess the easiest way to think about storage is you have a flash drive or a hard drive wherein you keep your files, right? That is storage for you. Now, inside the CPU, they also have their own storage, right? They have what they call registers. The storage of registers are really, really small as compared to what we have in flash drives or in hard drives, okay? But they are really small, but they can easily be accessed by the CPU. So mostly all things that are immediately needed by your CPU is stored inside these registers. They are stored inside temporary use only. If you need something stored long term, right, it is either kept in your main memory or your RAM or secondary memory. Secondary memory are your flash drives and your hard drives. Okay? So take a look of this image first. This is the memory hierarchy of in computer architecture. Think of registers as your pockets, okay? They are corresponding. Think of registers as your pockets. And you are the CPU, okay? Think of yourself as the CPU, as the processor. You can easily access your pockets, right? But the problem of your pockets is the storage is only really small. I mean, you don't even have to twist your body to check to get stuff from your pockets, right? So you can easily access them, but the storage is really, really small. Now think of your cash as your backpack. You have more space, yes, right? You have more space in your backpack, but then it would take you more time to get your things from your backpack as compared to your pockets. So as you can see, the hierarchy goes. Next, you have your main memory. We call main memory RAM sometimes, right? Random access memory. Think of it as your locker. It has more space. It is somewhat limited, right? But you don't always have it with you. So if you need to get something from your locker, you actually have to take more time to get it. And last of which is your secondary memory. Think of secondary memory as your house. You have so much storage. Now even thought to be unlimited storage, right? Because of cloud storage, if we would think about it in secondary memory. But to get those files, if you were the CPU, it would take significantly longer. So as you go through the hierarchy, right? Oh, as you would go through the hierarchy, wait, this should be, wait, let me just fix this a little bit. I'm sorry. This should be storage. Yeah, and this should be speed. There you go. I fixed it. Sorry that I didn't see that earlier. But yes, as you go through the hierarchy, the storage increases, but as you go down the hierarchy, the speed increases. Okay? So those are your registers. They are the memory inside your CPU. So more things to tackle about your CPU are your power and your speed. Okay? We will be talking about the characteristics of a CPU. Let's start off with clock speed. Computers execute their instructions based on a clock. Per impulse of the machine, an instruction is being executed. So these are your impulses on the bottom side, right? So on one impulse over there, an instruction will be executed. Okay? So depending on how many number of pulses you have, depending on the number of waves that you have, those are the instructions that are being executed. So imagine a standard processor right now has, about 3.4 gigahertz to 3.8 gigahertz. So gigahertz meaning the billions of cycles per second. So 3.4 gigahertz means that you are executing over 3.5 billion instructions every second. That's how fast your computer is running right now. You're able to execute over 3 billion instructions per second. Okay? People usually ask, why can't we just increase the clock cycle time of our CPU so that it would be faster, right? I mean, the more clock cycles that you have, the faster that it can run, the faster your computer is. And the short answer for that is the enemy of your clock speed is heat. The faster the clock cycles are, the more heat it produces, and hence risks your system to overheating. So that is why we don't, I mean, only large computers have a 5 gigahertz speed for their computers, the more powerful ones, because they have specialized cooling systems to handle these types of speeds. Okay? Yeah. So let's move on to the characteristic, or what is the CPU made of. Okay, CPUs are made of silicon. That's pretty much it. It is made in an extremely sterilized area where little to no dust is present. I'll be sharing a video on Moodle on how to make or how they make these silicon chips or how they make these CPUs. Okay, most CPUs are collections of digital circuits imprinted on silicon wafers or chips, each no bigger than the tip of a pencil eraser. Okay, okay. Whew. Last up on processors is multiprocessing. Okay, so multiprocessing refers to the simultaneous execution of two or more instructions. A basic computer, okay, a basic computer with one processor, okay, think about only one processor, like the most basic ones that were released, let's say, 15 years ago, can only execute one instruction at a given time. That is how processors work, okay? They can only read one instruction at a given time. So one clock cycle time equals to only one instruction being executed. So here we have multiprocessing, okay, which is the simultaneous execution of two or more instructions. The different types of multiprocessing is, first, multi-core microprocessor. This is where you have one CPU chip. Okay, you have one chip, but in a computer unit, but that CPU has multiple independent processors inside of it. This is when the terms quad-core, octa-core concepts come from, right? You have only one chip, but there are many cores inside. You have one chip, right? You have one processor, but there are multiple cores inside. So in a chip, you have multiple processors. Okay. Next up is parallel computing. In this case, the computer unit has multiple chips in the CPU. These chips may have multi-core or only have a single core. It depends on how you build your CPU. But the computer, okay, so the key thing here is the computer is running on multiple processors, meaning it has many chips inside that computer. If in multi-core microprocessor is you have one chip with multiple cores, in parallel computing, you have multiple chips in a computer. Okay? Last is grid computing. This is when you use multiple computers. It can be any build, parallel or multi-core. It really doesn't matter. But this is when you have multiple computers often owned by different people to achieve a common task. An example of this is Bitcoin mining. They use many computers in order to mine Bitcoins because it takes a lot of computer power to get Bitcoins. I will post a link on Moodle on the article of how Garena Plus, or a gaming platform, used players' computers to mine Bitcoins. Okay, so do look into that. So, that ends processing. Now let's move on to storage. We will be talking about what bytes are, right? So, as said earlier, computers work with ones and zeros. And this is how they keep and capture data as well, through ones and zeros, right? Instructions are received through ones and zeros. And whenever you are saving things, it is kept in ones and zeros as well. We are in a digital age. And so, given that, we keep data through bytes. Okay? This term should be familiar to you right now, right? What bytes are: gigabytes, kilobytes, megabytes, and so on. So what are bytes? Remember our binary integers, right? One binary integer is called a bit. So a binary integer, one transistor is called a bit, right? So we have eight. So if you have, so wait, sorry. A binary integer is called a bit. So if you have 8 binary digits or 8 bits, okay, you have a byte. So as seen in this picture over here, 8 bits make a byte. So okay, let's move on. Hopefully that is enough for you to understand how data is kept. They are kept in bytes, they are kept in ones and zeros, so they are 8 bits or 1 byte. There are two main types there are two types of storage. You have your temporary storage and your permanent storage. Let's start off with the temporary storage, okay? So, temporary memory is volatile. Volatile memory means that when your power, when there is no electricity passing through your computer, everything stored in this memory will be erased. Included in temporary memory are your registers, your cache, and your main memory or your RAM. Okay, as written, RAM is over here. If you would notice from the earlier slide, right, our hierarchy over here, um, these memories, the ones that are temporary, registers, cache, and main memory, are the ones closest to your CPU. They are the fastest ones to access by the CPU. Thus, they need to be erased often when the computer is shut off to free up space for the next use. Okay, because if you have a lot of things stored there, it would be just cluttered up and access time would be slower. Okay, so in temporary memory, writing data is faster, though it is volatile, meaning if you turn the power off, everything written on there will be erased. The capacity of your random access memory can reach up to gigabytes of data, right? The largest chip that I can recall right now, right, is the 16 gigabyte RAM, 16 gig RAM. That's why it reaches up to gigabytes of data. But don't get mistaken that your cache and your registers don't even reach gigabytes of data anymore. They can only be up to kilobytes or megabytes of data. All right. Okay. Moving on. We have our permanent memory. These are volatile memory. Sorry. These are non-volatile memory. Okay, meaning when the power is turned off, your data will still be there. Under permanent memory, we have our read-only memory or ROM. Um, the ROM is a chip with a small amount of storage that is found on your motherboard. Okay, it's a different type of chip that stores memory as well. Um, it it is permanent memory, but writing data on there is slow. You rarely actually touch your ROM, like normal users rarely touch their ROM because this chip over here includes the startup routine of your computer, your BIOS, and your firmware. Those are the things that you rarely touch, and they will only be touched whenever there are updates to your computer, like a system update, Windows update. That is the only time when read-only memory will be touched. Okay? So next up, we have our secondary memory. I think everyone is familiar with this on what secondary memory is. This is where we save our files. Okay? Examples of secondary memory include your flash drives, your CDs, your hard drives, your solid state drives, right? And even the cloud, which includes your Google Drives, OneDrives. Those are all examples of secondary memory. Okay? Again, they are non-volatile. They have great capacity, right? We can reach terabytes or petabytes of data. We have unlimited storage. Um, they are less expensive per byte, right? Buying a flash drive, buying a 16 gigabyte flash drive is much cheaper than buying a 16 gig RAM, right? It's much cheaper because it is considerably slower than main memory. Okay, so those are the types of memory. And the last topic that we have for our hardware is the types of computer systems. Okay, so we have our single user systems, ones that we are familiar of, right? They can be either portable or non-portable units. So we have our uh, these include our handheld devices or our smartphones. It includes our laptops, notebooks, netbooks, and tablets. All that can be seen here in our table. Okay, so these are our portable single-user devices or single-use computers. Single user meaning only one person uses them, right, at a given time. So if you have a phone, like most likely only one person can use them at a given time. If you have a laptop, it's only a single user, stuff like that. Okay, let's move on to our non-portable single-user systems. We have our thin client, desktop, nettop, and workstation. If I would categorize them, they would actually all fall under the same thing. They're all just desktops, okay? They are all desktop computers, but it becomes more powerful and much expensive as you increase in the tier. So generalize them all as a desktop. So think of them all as a desktop. A nettop is a much cheaper desktop, right? And a workstation is a much more expensive desktop. Um, if it is cheaper, it is less powerful, and if it is much more expensive, it is more powerful. But to generalize them, they are all considered desktops. Okay. So what I want to focus on here, actually, what might be new to you, are your multiple user systems. Your multiple user systems include your servers, your mainframes, and your supercomputers. Okay, you can see their price; they are very much more expensive. So why do we call them multiple user systems? Uh, so think of it this way: a server is a computer that can is a computer. Okay, it's a computer first and foremost that can be used or accessed by multiple people. So many people can use this server. We have different types of servers, such as a web server, our enterprise server, or a file server. So I'll try to explain what servers are. Okay, so Let's focus on a web server and how it works to give you a perspective. Imagine, okay, so here, imagine going to a website, okay? Let's say something we are all familiar with, moodle.ateneo.edu, okay? Imagine going to a website, moodle.ateneo.edu, and the website of Moodle is running on a computer, okay? Everything that's being managed in Moodle is being run on a computer found, let's say this computer is found somewhere in Ateneo. Yeah. Okay, so you have a computer in Ateneo running moodle.ateneo.edu. Okay, what do we mean by the website running on a computer? This means that the files for the website, such as how it appears, the classes that are posted, the materials that we teachers post, such as the syllabus and other slides, our videos, are being sent to that computer. Okay? If we want anything posted on Moodle, we would send the files to that computer. So yes, all the files of a website is found on that computer. Now, this computer can be accessed by multiple people. How do they access it? Through the website, right? Multiple students and teachers simultaneously access moodle.ateneo.edu, meaning that all the things that we do on the website, on moodle.ateneo.edu, is being processed on that computer found in Ateneo, where we have all our files in. Okay? And because this computer is being accessed by multiple users, this is what we call a server. So a server is a much more powerful computer. Okay, don't get me wrong, it's a computer, but it's a more powerful one that can simultaneously handle multiple users at a given time. That's why when, for example, Moodle goes on a server maintenance, right, quote unquote server maintenance, no one can access the site because they are performing maintenance on these computer servers. Okay, so just a trend right now for servers is to go for online services. Okay, that provide servers for you, such as Amazon Web Services, because investing in buying your own local servers, like if you would have to buy a computer yourself, like a server computer yourself, it's going to be much more expensive than paying a subscription fee to these online services. Whew. Okay, next up, we have our mainframes. Take mainframe as a bigger server and a much more powerful one. They achieve the same purpose, but it can handle more load. And because it's more powerful, right? This mainframe is bigger and more powerful than your normal server. It generates more heat. Therefore, you need to keep it in a place with special heating, ventilation, and air conditioning equipment, or HVAC equipment, in what we call data centers. We will be explaining data centers later when we get to our databases and data warehouses topic. Okay, data centers are a specialized environment where you have specialized heating, ventilating, and air conditioning so that your computers or your mainframes won't overheat. Okay, and last off is our supercomputers. Supercomputers, on the other hand, are the same thing. They're just a much stronger mainframe. Okay, they're the most powerful, fastest processing speed, and highest performance. Okay, and with that, I will end our topic with green computing because this is also still considered included in hardware, right? Green computing is towards an efficient and environmentally responsible design, manufacture, operation, and disposal of your technology or in IS related products. Okay, the goals of green computing are to reduce the use of hazardous materials in making technologies, and also to enable companies to lower their power related costs. So yes, basically this means going green is good, right? We can do green computing as well in our own homes. For example, don't just throw away technologies or batteries into your trash can. For example, you have a broken battery, right, for your laptop, just don't throw it in the trash can. Dispose of them properly. If I'm not mistaken, before at least, Ateneo had a good waste management system or management program to properly dispose of stuff like these. So do check them out. Okay. Before they had a trash can, specialized trash can in Faura wherein you can dispose of your technologies. You can throw away your batteries there. You can throw away your laptops that you don't use anymore, so that they can properly dispose of them. Okay. And with that ends our video on hardware. See you on the next video where we talked about software. Okay? Thank you.